Hello everyone, welcome to the next lecture on the partial derivative. Today I will explain you how you can solve the implicit functions. Myself Dr. Harish Garg, you can follow my YouTube channel where you can find the playlist of the mathematics 1. In this playlist you can see the lecture related to the limit, continuity, the chain rule, direction derivative, all are available in this playlist. I hope you can subscribe my YouTube channel so that when I upload the next video you will get the notification. Now consider the two equations. Fine, I have chosen the two equations at a randomly. Now the question arises is, can you find the value of the y easily from the equation number 1 and easily from the equation number 2? Also, can you find the value of the x in terms of the y from these equations? Definitely your answer is no. Why? You can see that from the equation number 1 you are unable to find the value of the y in terms of the x. Similarly, because of this sine y over x, you are unable to write the value in terms of the fx or fy. So once you are identifying such kind of the equations, that equation is called as implicit equations. That means if you are unable to write any of the expression in the form of y is equal to fx, such type of the equations are called as implicit equations. On the other hand, if you look about this example, then clearly say you can find the value of the y as 4 minus 3x divided by x square minus x. That means you can write this function in the term of y is equal to fx. Then such equation is called as the explicit equations. Fine. So the smallest difference is the explicit is if you are able to write the function or equation in the term of y is equal to fx, then you can call as the explicit function. If you are unable to write this function, then we call as the implicit equations. In general, we can say any of the function f of x comma y or x1 comma x2 comma xn is a 0 and you are unable to write in the term of y is equal to fx, then this is called as the implicit equation. Make sure student the right hand side must be 0. Fine. If I say simply x square plus y square is equal to r square, because the right hand side is non-zero, I have to firstly convert them into the right hand side 0. Then this equation or this is my f of x comma y. This equation is called as my implicit equations. Although you can write the value of the y in terms of the x easily, fine, but I can also say this is my implicit equations. Now, and this function f is called as the implicit function. If I consider this example, can you identify what is the implicit function? F of x comma y, that is the x square plus y square minus r square is my implicit function. Once you are able to identify the implicit function, then your target is how you can find the derivative of the functions. For example, how you can calculate the dy over dx from these equations. I am very sure that you can easily find the derivatives by using simple derivative rule. Plus, I can use the product rule, x dy over dx plus y is equal to 0. I can find the coefficient of the dy over dx, which is x minus 4y, which is equal to minus y minus 3x square. Then dy over dx will be, I can take this component as my division side. Fine. Now, if you look about these calculations, and you can see you have to do a lot of the calculations. Fine. If I write some another function, say sine of x square into y and so on, then you have to do a lot of the calculation. That means your process is a very messy process. So now in this lecture, I will tell you the simple way with the help of the chain rule how you can find the dy over dx or any kind of the derivative in a simple manner. So let's see, I will explain you with the help of the firstly two variable. Now consider the function f of x comma y is 0 such that x is my independent and y is my dependent. Then your target is to find the value of dy over dx. Fine. Now if you are able to write this function in the term of the explicit, then you can easily find this But if it is an implicit function, then how you can find that? Now clearly say from this function, if I take derivative with respect to x, because the right hand side 0, this is also my 0. Fine. Now I can use the chain rule. Fine. How you can apply the chain rule? For more detail, you can watch about this lecture of the chain rule. The function f is dependent upon the x, function f is dependent upon the y, and since we are needed with respect to x, I can write this expression. Now can you find that derivative of x with respect to x is a 1, derivative of y with respect to x is dy over dx, partial derivative of f with respect to x is fx, this is my f1. Fine. Now what is the df upon dx? I can say this is fx into 1 plus fy into dy over dx is 0. Now can you find the value of the dy over dx? So now the dy over dx is minus fx over fy, and that is the quite easiest way to solve the problem. Fine. Where what is the meaning of the fx? Fx is my partial derivative of the f, is a partial derivative of f with respect to x. Now the question arises is how you can remember this formula. That's a very simple. For example, how you can remember that dy over dx is equal to minus whatever you have written is a denominator, partial derivative of the function with respect to x, and then partial derivative with respect to y. Similarly, if you want to write as a dy over dz, that means minus f of the z divided by f of y. But make sure for that case you have to write the function in the terms of implicit form. Fine. Now if I consider 3 variables, again I have to write the chain rule. X over x is 1 because y and x are independent, so the derivative is 0. This part is my dz upon dx. This part is my fx, partial derivative with respect to x, y and z. Now if I do partial with respect to x, because the right hand side is 0, so if I again by the chain rule, I can write this is fx into 1, fy into 0, plus because it involves more than one variable, then instead of the total derivative I have to use as the partial derivative. So fz into del z by del x is 0. So can you find the value of the del z upon del x? So again it is a similar of the previous one, minus fx over fz. Again you can see this is my fx and fz. Similarly, if you want to write the del z by del y, you can write as a fy over fz. Now look at this one. I will tell you the two different methods. The first method that is you have to done in your lower classes. How you can do that? I can differentiate this equation partially with respect to x. I can write this equation in terms of this value, partial of x plus y. Fine. Now how you can do that? Because I have to do the partial with respect to x, y is my constant, because in this case we have observed z is my dependent variable. So del z upon del x minus 1 over z del z upon del x, which is equal to 1 plus 0. So can you find the value of the del z upon del x, which is equal to y minus 1 over z is equal to 1. I can take the LCM and then cross multiply. It's a z over yz minus 1. Fine. Now you can see that you need to do the product rule, you have to do something else. But I will tell you the second method, which is by using the chain rule. First of all, you have to write this equation in the implicit form. The right hand side must be 0. So how you can do that? I can put x plus y on the left hand side. Minus ln z minus x minus y is equal to 0. So this quantity is called as the function of x, y and z. Fine. So I take the function f is yz minus of this. Now your target is to find the value of, so how you can write that? Is a minus fx over fz, the x independent variable over the dependent. Now can you find the value of the fx? do the partial fraction of the f with respect to x. Is a 0, 0, minus 1. Partial derivative with respect to z, y minus 1 over z. Now you can take the LCM and you can see the same answer we have obtained in this case. And you can see in this case you need only the 2 steps to get the right answer. Look at this another case. Again you can see I need to find the value of the del z upon del x. So firstly we need a f. I can write in the implicit form because the right hand side is already 0. So f is my xy plus and so on. Your target is to find the value of del x upon del z. It's a minus fx over fy. Similarly, how you can find the value of the del z upon del y? It is minus fy over fz. Fine. Now you can substitute the value. It's a minus. What is the partial derivative with respect to x? Y plus z cube divided by f of z. 3 z square x minus 2y. Fine. Similarly, you can find the partial derivative with respect to y is a x minus 2z and so on. Now your target is to find the values at the point 1, 1, 1. So what is the value of the del z upon del x at the 1, 1, 1? It is my 2 divided by 1 minus 2. Del z upon del y is a minus 1 over 1, that is plus 1. Fine. Look at the next one. Again you can see the right hand side is a non-zero. So firstly you can take the function, put x z plus y ln x minus x square plus 4, so that the right hand side is a 0. Now your target is to find the del x upon del z and del y upon del z. How you can write that? It's a minus f of the z divided by f of x. Similarly for this case, f of z divided by f of y. Fine. So now you can substitute this value. What is the f of z? You can take the partial derivative with respect to z. It's a x. With respect to x is 1 z y over x minus 2x. Similarly for this case, you can find the values of the fy, only this case and so on. Fine. Otherwise, you can also do by the partial. Firstly, you can do the partial derivative with respect to z. So what you do, I have to use the chain rule. This is the second method. Plus 1 into z plus y is a constant, 1 over x into del x upon del z, which is my 2x del x over del z minus 0. And you can find the value of the del x upon del z. You will see the same result will be appears. Fine. Now this is y over x with respect to z. Fine. Now at the point 1 minus 1 minus 3. What is the value of the del x upon del z? Fine. So you can substitute this value. It is my minus x is my 1 divided by z. What is the value of the z? Is minus 3. Y over x is a minus 1 minus of 2. So that will be my 6, 1 over 6. Similarly, you can find the del y upon del z at the point 1 minus 1 minus 3. So minus ln of 1 is a 0 divided by minus 3 minus 1 minus of 2, that is my 0. So the answer is 1 over 6 and 0. So that's a 1 over 6. Basically it is my x. Fine. Partial derivative of this with respect to x is a y over x. Look at this another one. Again the right hand side is already 0. So this function is my f. Then my target is to find the del z upon del x. Can you find the value? What is the partial derivative with respect to x? 3x square. This is 0. This is my y into z e raised to power x into z divided by, with respect to z is twice. This will be my x into y e raised to power x into z plus cos y. Similarly, for this case, partial derivative with respect to y is a 0 plus e raised to power x into z minus z into sine y divided by fz, which is twice of z, x into y plus cos of y. Fine. Now your target is to find the values at 0, 0, 0. So del z upon del x at the point 0, this number is 0, this is my 0, 0 plus 0 cos 0 is 1, so answer is 0. Del z upon del y is e raised to power 0 1, 0, 0 plus 0 plus 1, so the answer is minus 1. Look at this another case. Your target is to find the dy over dx. So the right hand side is already 0. Fine. So then you can find the value of, taken the value of the f. How you can write the dy over dx is a minus fx over fy. So what is the value of the fx? Partial derivative with respect to x, 3x square plus y divided by partial derivative with respect to y minus 4x plus x. This is the first method. Otherwise, you can do the second method is how you can find the dy over dx. That you can do that. You can simply do the partial derivative. You can do the differentiation. 3x square minus 4y dy over dx plus x dy over dx plus y is equal to 0, and you can find the dy over dx. But you can see from this case you can get the answer in a one step. Then you can find the values at the point of 1 comma 1. What is the value of the dy over dx? Minus 1 plus 3 plus 1 is 4, minus 4 plus 1 minus 3. So the answer is 4 over 3 is the right answer. Look at the second part. Now this is my f. I can write this function f. Again, your target is to find the dy over dx. So that will be minus fx over fy. Fine. And you can easily find the what is the partial derivative of f with respect to x divided by y. At the point of minus 1 comma 1, what is the value of the dy over dx? At the point of minus 1, it is 1 minus 3 into minus 1 plus of 2. That will be my 2 over 1. That's a 2 is the right answer. Look at the third part. Fine. Again, the first method is you can do the product rule or simple derivative without the chain rule. Fine. Plus 2y dy by dx minus 0 is equal to 0. I have to do and find the value of dy over dx. Fine. Otherwise, I can use the chain rule. The second method is I can use the chain rule, and that is quite easy to calculate the derivative. Minus fx over fy. What is the value of the fx? 2x plus y divided by partial derivative with respect to y, x plus 2y. Fine. Now at the point 1 comma 2, what is the value of dy over dx? 1 plus 2, that is a 3 divided by 1 plus 4, 5. So minus 3 over 5 is the right answer. So it's a 2 plus 2, sorry, 2 plus 2 is 4. 2 into 1 plus 2, so 4 over 5 is the right answer. Similarly, for the last case, my function is this. So can you find the partial derivative with respect to x? It is e raised to power y plus y into cos xy divided by partial derivative with respect to y, x into e raised to power y plus x into cos xy plus 1. Fine. Now your target is to find the values at 0 comma ln 2. What is the value of the dy over dx? So at the point of y is equal to ln 2. So e raised to power ln 2. E raised to power ln 2 is my 2. Y is my ln 2. Cos of 0 is my 1. Divided by x. X is my 0. X is my 0 plus 1. So the answer is minus 2 minus ln 2. Now look at this case. Now your target is to find the partial derivatives of the function. Again, we can take the f is my this case. Then how you can write this function? Minus fx over fz. Similarly for the second case, del z upon del y is minus fy over fz. Now you can calculate this value. What is the partial derivative with respect to x? Minus y is 0, 0. With respect to z, 3z square, 0 plus y. Similarly for this case, can you do the partial with respect to y? Minus x plus z plus 3y square divided by, with respect to z, 3z square plus y. Now at the point of 1, 1 and 1, you can substitute this value. What is the value of the 1, 1, 1? So 1 over 4. What is the value of the del z upon del y? So 1, 3, 3 over 4 with the negative sign. So minus 1 over 4 minus 3 over 4. Look at the second question. Because the right hand side is a non-zero, I can put on the left hand side. Fine. So that is my minus. Then again it will be my minus fx over fz. So what is the value of the fx? Partial derivative with respect to x, minus 1 over x square. Partial derivative with respect to z is, and 1 minus is already here. So the expression is minus z square over x square. Similarly for this case, it's a minus 1 over y square divided by minus 1 over z square. It's a minus z square divided by y square. At the point of 2, 3, 6, fine. At the point of 2, 3, 6, what is the value of the del z upon del x? Minus z square over x square. That will be my minus 9. And what is the value of this case? It's a minus 36 divided by 9. That is my minus 4. So minus 9 and minus 4 the answers. Similarly, look at the third point. This is my fx. Then del z upon del x is my minus fx upon f. So what is the minus? Can you calculate the value of fx partial derivative with respect to x? Cos x plus y into 1. There is no x, that's a 0, plus cos x plus z divided by partial derivative with respect to z. There is no term, that's a 0, into cos y plus z into 1 plus cos x plus z. Similarly, you can find the value of the fy and fz. Now, at the point of pi, comma, pi, comma, pi, what is the value of the del z upon del x? So clearly say it's a minus cos 2 pi. So we all know cos 2 pi is my plus 1. This is plus 1. Denominator is also plus 1 and plus 1. That's a minus 1. Similarly, what is the value of the del z upon del y? It is again a cos of 2 pi. It's a 1 plus 1, 2. 1 plus 1, 2. Again minus 1 is the right answer. Look at the last option. Your target is to find this value. Again, what is the value of the fx? It's e raised to power y, 0 plus 2 over x divided by, with respect to z, it's a y e raised to power z, 0, 0, 0. Similarly, for this case, partial derivative with respect to y, x into e raised to power y plus 1 into e raised to power z, rest are 0, divided by y into e raised to power z. At the point of 1, ln 2, ln 3. Fine. What is the del z upon del x? It's a minus e raised to power y. Again, e raised to power ln 2 is my 2 plus 2 over 1 is my 2 y. Y is my ln 2 into e raised to power z. E raised to power z is my 3. So 3 ln 2. That is my minus 4 over 3 ln 2. Similarly, I can substitute this value in the del z upon del y. We will get the answer as minus 2 by 3. Okay, look at this one. The resistance R1, R2, R3 are connected in parallel. So this is my resistance R1. This is my resistance R2. This is my resistance R3, which are connected in parallel with the voltage. Fine. The value of the R is found by this method. Then your target is to find this expression. Fine. Again, there are the two methods. I will tell you. The first method is by using the chain rule. First method I will explain you the chain rule. So for the chain rule, you need a F because the right hand side is a non-zero. I can move all those values in the right hand side or in the left hand side. Fine. Then what is the value of the del R upon del R2? It will be minus F with respect to R2 divided by F with respect to R. So now can you find the value of the F with respect to R2? This is a 0. This is 0. It is 1 over R2 square minus minus plus divided by with respect to R is a minus 1 over R square. So the answer is R square over R2. Now at the point of R1, R2 and R3. So what is the value of the, because we need R also, so I can substitute this value 1 over 30, 1 over 45, 1 over 90. So you can take the LCM. So 180 will be the LCM. 6 plus 4 plus 2. Fine. So it will be my 10 and 12 is a 180. It is 115. 1 over R is equal to 1 over 15. R is 1 over. So R is my 15. So I can substitute this value. So value of this is my R square. R is my 15. What is the value of the R2 is 45 square. So the answer is 1 over 9 is the right answer. This is the first method by using the chain rule. Second method is how you can find this second answer. You can directly differentiate this function with respect to R2. So what is the value of this? Minus 1 over R square del R upon del R2. 1 over R1 is 0. 1 over R2 is minus R2 square. R3 is my again 0. So what is the value of the del R upon del R2? So I can cross multiply them. It's the R square over R2 square. Again, at this point, I have obtained the value of the R is my 15. I can substitute this number 15 into 15 divided by 45 into 45. So clearly say it is 1 over 9 is the right answer of this problem. So based on your choice, but I always recommended you can apply the chain rule so that you can get your derivative in a very simple manner. For more detail about the chain rule, I recommended you strongly you can watch this lecture of the chain rule. I hope you can like, comment and share this video with your friends. We will see the more lecture on the directional derivatives in our next part. Till then, you can share this video with your friends and don't forget to subscribe my YouTube channel. Best of luck students and thanks for the watch.